Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. So within this module, we are trying to understand how the operating system manages the CPU by providing the abstraction of a process. So within this second module, we are currently on the first topic, that is process introduction. And in this topic, through a series of videos, we try to understand what is a process, how is it different from a program. Then after that, we talked about how does the operating system represent a process. And finally, we talked about the life of a process in the previous videos. So now we are reaching the end of this topic, and I want to summarize all of that we just studied in this topic with a interesting analogy. Basically, as you can see, the time sharing ideas that we studied. First of all, why are we studying all these concepts related to a process? Because we want to time share the CPU among the different running programs. That is why the idea of a process comes into the picture, right? So in this video, what I'm going to do, I want to summarize all of those ideas that are related to this time sharing and this process with an analogy. And what is this analogy? It's a music DJ analogy. Basically, all of the ideas that we studied are very similar to what a music DJ does. Sounds quite interesting, right? So let's start this video and see how the ideas that we have just studied in the context of time sharing are very similar to what a music DJ does. So let us start this discussion by recalling one of our previous videos where we talked about the differences between a program and a process, right? So there we also studied one analogy. We said that a program is very similar to a music CD, whereas the process is very similar to the music CD being played, right? So this was the analogy that we discussed in that video. So let us briefly recall that analogy. Why is a program very similar to a music CD? So first of all, what is a program? A program is a binary file which contains the instructions and data, and you get a program after compiling the source code, right? So basically, first of all, you write your source code in some high level language like C, C++, or Java. And then when you compile that source code, that is when you get a program which is a binary file which contains the compiled instructions and data, right? And it is very similar to a music CD because you can see that the music CD is also a file. It's a storage medium on which the musical notes have been recorded, right? Both the program and the music CD are passive entities. As such, when I say passive entity, I mean that these are just files and no activity is going on, right? Now let's talk about a process. A process is a running program. So when a process is running, then the instructions of the program, right, that they are getting executed by the CPU, and some useful activity is going on. Basically, the input data is being processed to generate some new output, right? The user will be interacting with the process. So here the activity is going on, which is very similar to the music being played, right? So if you put this music CD on this music player and start playing it, that is when you will see some sound being generated, the music being played. So the music player, it will be decoding the musical notes that have been recorded on the CD, and then after decoding it, it will be generating the music, right? So here is where the activity is going on, very similar to a process where the instructions of the program were actually getting executed. So here, both in the case of the music being played as well as in the case of the process, some meaningful work or activity is going on. So this was about the analogy. So what I want to do in this video is that I want to extend that analogy to cover some more ideas. Basically, why are we studying program in a process? The bigger picture is that we want to time share the CPU among the different running programs in the system. Once we are able to time share the CPU, then we will be able to run more programs than the number of CPUs that are there in the system. So the ultimate goal is to perform time sharing, right? So what I want to do is that I want to talk about an analogy which will help us to understand the entire time sharing, right? So till now, this music CD analogy is limited to explaining or relating with the idea of a program and a process. So these program and process are subsets, or you can say parts of a bigger idea of the time sharing. And I want to develop a bigger analogy which will cover the entire idea of time sharing. So that is why we have an analogy between a music DJ, which will help us to understand the idea of time sharing. So let us now understand how the activities that a music DJ does is very similar to what an operating system does when it is doing the time sharing. So now let me explain you the analogy that I have been talking about, that is between a music DJ and the operating system. So here we have our music DJ, right? And what we are going to do, we are going to see how the activities that the operating system does during time sharing the CPU among the different programs in the computer system is very similar to what the music DJ does when they are playing different types of music, right? So let us understand this analogy with an example. So let us first of all recall the concept of time sharing, and then we will be able to correlate this with the analogy of music DJ, right? So as you can see here, we have a computer system. There is one single CPU in this system. This is a hypothetical example, right? So here there are n different programs that want to execute on the CPU, right? Now we know that the constraint with the CPU is that it has been designed in such a way that it can only execute a single program at any given point in time. So if you talk about any particular time instant, then the CPU can only execute one single program, right? So now as you can see, we have n different programs and only one single CPU. So how we'll be able to run these different programs on the CPU? We know this, right? So there is this concept of time sharing. So what the operating system does is that it shares the CPU between all of these different programs. So the sharing happens in this way that the operating system allocates the CPU to each program, and it allows each program to run for some brief period of time. So in that time, the program executes its instructions and makes some progress. And after that, the operating system, what it does is that after the program has run for some amount of time, it takes away the control of the CPU from that program and gives it to another program. And in this way, the operating system frequently switches the control of the CPU between all the programs that are there in the computer, right? This is how the operating system shares the CPU time between all of these different programs, right? And this is where the concept of a process comes into the picture. So basically, the operating system, it has to, if it has to properly perform this time sharing, then it must be aware of all the running programs in the system, right? So that is where the operating system models each running program as a process. So the operating system keeps track of all the running programs or all the processes in the system and assigns the CPU to these processes so that each of them can execute instructions and make progress, right? So this is how the concept of time sharing works, right? And this enables the end user, that is us, to launch as many programs that we want, right? So we can launch programs, and irrespective of the number of CPUs that are there in the system, what the operating system will do, it will whichever program that we launch, right, it becomes a running program, right? So from the perspective of the operating system, it is a process, and we know that the operating system will allocate the CPU to each of the process in the system, right? So this is how we as end users are able to launch way more number of programs than the number of CPUs that are there in the system. So this is how the concept of time sharing works. So now let us correlate the ideas that we just discussed with the activities that a music DJ does when they are playing the music. So now let us discuss the example of a music DJ and correlate what we just studied in the context of time sharing with the DJ example, right? So let me quickly talk about what the DJ does. So here is our DJ and he's trying to create a music mashup. So what is a mashup? So basically a mashup is like a mixture of different songs. So what the DJ will basically do, he has different music CDs. All of the songs are recorded on these music CDs, and he will play these songs in some order. He can also repeat some songs, and by playing these music in different order, by mixing them in some way, he will come up with a mashup. So the crucial point here is that he has different songs, and he has to play all of these songs in some order, right? So this is the crucial part, and you can see there is a single music player in this case. So let's make an assumption that this music player can only play a single song at any given point in time. So there could be the case that we have music players today which can play multiple songs, but generally when we talk about a music player, it can only and play a single song at a given point in time. So that is what we will assume in this case. So the basic setup is something like this. There is a music player which can play a single song at any given point in time, and this our friend DJ wants to make a music mashup by playing different songs, right? He will be switching between the different songs, he will be mixing them in some order, right? So you see how this situation is very similar to this case where we had a computer system. There was a single CPU, right? And there were different programs that wanted to run on the CPU, right? So this is very similar to this case. We have a single resource. The music player is very similar to the CPU. Just like the CPU can play only not play. It can only run a single program at a given point in time, and there are multiple programs that want to run on the CPU. In the similar way, here we have a music player which can play only a single song, and the DJ has to play different songs, right? He has to mix these songs in some order, right? So just like in the case of the computer system, the operating system solved that problem by time sharing the CPU between all the programs that wanted to execute on the CPU. In the same way, our DJ friend will also do the same thing. He will time share the music player among all of these music CDs. He will play a song for some amount of time, and then he will switch to some other song. So one clear point that I want to make here is that the goal of the idea, the DJ does not want to time share the songs as such, like in the case of the computer system. He just wants to create a mashup. But the thing that the way in which he's playing the songs is very similar to the way in which the operating system runs the different programs on the CPU. So just like in the case of the computer system, the operating system allocated the CPU to different programs for some amount of time. In a very similar way, while creating a mashup, the DJ is playing each song for some amount of time and then changing the music. And by playing all of these different songs in some order, he is able to create a mashup, right? So you can see how these two examples are quite similar, right? And the thing here is that this is an extension of the analogy that we already discussed. So we had this analogy that the music CD is like a program, and the music CD being played is like a process, right? So in the just extending that idea here, now we are correlating other pieces also in this broader idea of time sharing. So we are basically saying that the CPU is like the music player, okay? Then the operating system is like the DJ, and what the operating system is doing, that is, it is time sharing the CPU among all the different programs. This time sharing is very similar to what the DJ is doing in this case. He's playing different he's playing switching the different songs, right? So he's playing some song for a brief amount of time, then switching it to some other song. So this switching of songs that the DJ is doing, this is very similar to what the operating system does when it is time sharing the CPU among all the programs. So in this table, I have listed down the ideas that are very similar. So we have already said that the program is like a music CD. The process is like the music being played. Now extending this idea further, so we can say that the CPU is like the music player. It is a resource, right? And this resource is required to, for example, in the case of the computer, the CPU is required to run the program. Similarly, in the case of the DJ, the music player is required to play the music. And we put a constraint that the music player can only play a single song at any given point in time, just like the CPU can run only a given program at any given point in time. And now in the case of the computer system, we wanted to run multiple programs at we want to run the multiple programs on a single CPU. In the same way, in the case of the DJ, he has to create a mashup. He has to play all of these different songs on the single music player, right? And in order to do that, he will be switching the music player between different songs, just like the operating system time shares the CPU between the different programs, right? So our operating system is very much like what the DJ is doing. So we can have this analogy, we can draw parallel between the two ideas of these examples. So one thing is that you might find certain things which are not similar in the two cases. Don't try to draw a very exact analogy. It's just to give you a basic idea. There might be things in both the examples which are very different, but just to give a basic idea, I have created this analogy, right? So let's discuss some more points about this analogy. So now what we are going to do, basically all the videos that we studied in the previous the previous videos that we studied in this topic, right, related to a process, we are just going to quickly go over them one by one and try to fit whatever we learned there in some way to our this DJ analogy that we just studied, right? So basically we want to fit the idea of time sharing or correlate this idea of time sharing with this DJ analogy, and the different pieces in this time sharing, whatever we studied, let's try to correlate that to our analogy in some way, okay? So in one of the previous videos, after we studied the difference between a program and a process, right? So after we studied the distinction between a program and a process, then we moved on to understand how a program becomes a process. That is the journey from a program to a process. There we studied how the operating system, given an executable file, given a program, how it launches it and makes a process. Okay. So this slide is taken from that only. So basically, I'll just quickly go over what we discussed in that video. Here is the source code, and when you compile the source code, you get a program, right? So this is the program, the hello.exe file, which resides on the disk. And whenever a user clicks, like double clicks on the icon, or via the command line terminal conveys their intention that they want to launch a particular program, then the user interface software requests the operating system to launch the program for the user, right? And then the operating system uh, basically loads this binary file into the memory, creates an address space like this, right? And then does some other setup also, like setting up the IO devices, setting up the CPU registers, the program counter, the stack pointer. So we have discussed this in great detail in that earlier video. So the basic idea here is that given a program file, what all the operating system does to launch a process, it sets up the different things, just like we discussed about the memory, the IO devices, the CPU registers, right? And that is how a process is created. So let's correlate this with our DJ analogy. Just like the operating system has the task or responsibility of creating a process out of a program, like launching a program and getting a process. In a similar way, in this case, in this our DJ example, whenever the DJ has to play a certain song, right? So first of all, there would be some music CD which is analogous to our program, and then whenever the DJ decides to play a particular song, then he has to search through his collection, get that music CD, and then put it on the music player, set up some settings, and then he can hit the play button, right? So this uh, part, that is loading the CD to the music player, we can consider this as very similar to how the operating system creates a process out of a program, right? Here the DJ is just getting the music CD and playing it on the music player. So this is how we can correlate that process creation part with the DJ playing the CD, right? There the operating system was taking a program and creating a process out of it. In the same way, here our DJ is basically figuring out the music CD that he has to play and then loading it into the music player. So this is how we can relate that video with this example. So after studying the journey of a program to a process, right, we then talked about how to represent a process. So a process is basically an activity, right? It is very different from a program, which is just a passive entity. It's just a file. A process is very different. It's an activity. And when we talk about a process, then a whole bunch of things are going on. That is, the instructions are getting executed on the CPU. The memory contains the data and the instructions. The IO devices are being used by the process for interacting with the user, and then it might also read some files on the disk. So basically it's an activity. So we had asked this question, that how can the operating system represent an activity like a process? So there we had said that what the operating system does is that it collects all of the information that are necessary to describe this activity, all of the information that is relevant to a process, and it puts it into a data structure which is called the process control block, right? So using a data structure like a process control block, the operating system can represent any process. All it has to do is collect all of the relevant pieces of information and put it in the process control block. So this process control block, there is one process control block for every process in the system, and it is very crucial. It is required to represent this activity, that is, it is required to represent a process, right? So using this process control block, the operating system has the idea of all of the different processes that are there in the system, and then it can also perform the time sharing. So let us try to correlate this with our DJ example. We'll try to draw a rough analogy so that the goal here is to not create this analogy. The goal here is to try to get a better feel of what we discussed in the time sharing concepts. Like, how can we understand process control block in a better way, right? So that is the goal. The goal is not to create a analogy, right? So if you think about process control block, like how should you think about process control block? So you can think about it in this way, that here, let's say the DJ, our DJ friend is trying to create a mashup. He's switching between different songs. So the playing of the song is what is analogous to a process. So here the problem will boil down to how to represent a song being played, right? So there is one thing, that is this music CD, which is analogous to a program. We don't need anything to represent a music CD, right? But how do you represent a music being played? How do you represent an activity? That is the problem, that the operating system tries to solve when it has to build a process control block. It has to represent an activity. So you can think it from the perspective of the DJ. He is trying to play different songs, and let's say he's playing a song A, then he plays song B, then he might decide to play song A again, right? So he has to keep all of these, he has to in a way keep track of all the songs that he is playing in his mind. So how can he keep track of these songs? He can just collect the relevant pieces of information that is necessary to describe a song, that not the song, the activity of the song being played, right? So what are the relevant pieces of information that you can think of when you think of the activity, that is the music being played? It could be at what timestamp the music is currently being played, right? At which like para or line currently the music is there. Then at what volume the music is being played. What are the different settings on the music player which the DJ is using to play the music, right? There could be different settings. There could be some settings for bass, some other settings also, right? So from the perspective of the DJ, he has to switch between different songs. And it might be the case that when he pauses a particular song and plays another song, let's say he is playing song A, then he decides to pause it and play song B, and he wants to replay that song A. He wants to play it exactly where he had left it, and in the same way, at the same volume, at the same settings. So here the DJ also has to kind of have a way in which he can represent all of the songs that he is playing. So he can keep track of these pieces of information in his mind, like at which line he had stopped the music, what was the volume like, what were the settings like. So whenever he wants to come back and replay that music, like play that music from where he had paused, then all of these pieces of information would be necessary. So in the case of the operating system, you see, when the operating system has to perform the time sharing, it has to keep track of all of these pieces of information, right? So that it can pause a process and then resume it exactly from where it had left it, right? So in the case of the DJ, he can remember all of these pieces of information in his mind. So the point is that trying to understand what is the problem that we had solved there, right? We were trying to represent a process which is an activity. In the same way, you can think that the DJ here also has to represent an activity, that is the song being played. So in a similar way, there we had collected all pieces of information, and those collection of information was a way to represent a process. In the same way, in this case also, when we talk about an activity like the music being played, here also the DJ has to collect all of the relevant pieces of information, just like I discussed the timestamp, the volume, or the settings, so that he can properly mix and play these songs in different order, right? Or create a mashup. So this was about how we can relate the part where we represented a process with this DJ example. Finally, we talked about how what is the life cycle of a process, right? We studied about the process state diagram, that is what are the different states that a process can be in during its lifetime. And this process state diagram was also necessary to perform the time sharing properly, right? The operating system must have a clear idea of what are the processes that are in ready state, so that it can make a selection whenever it has to, then which process is running, which are blocked, right? So having an idea of what are the different states that a process can be in and which processes are in which state is very crucial to perform the time sharing. So let's again try to correlate this with the DJ example, so that we have a better understanding of what the operating system was trying to do there. Okay, so we can correlate with the DJ example. We can understand it in a better way. We can think like this. So our DJ friend has to play different songs, and basically if he has the idea, like if he can remember some pieces of information, like which state each music is in. So for example, there could be certain songs that he has not played, right? So he has to mentally keep track of these pieces of information also, right? Which song he has played, which one is he currently playing, which ones he had played before but currently he has paused, and which songs he has played and now he won't be playing again. So having these pieces of information in his mind is also very crucial, because he has to whenever he has to switch a song, let's say the current song is being played and he decides, okay, now let's play some other song. So he has to have an idea that which are the songs he has not played, which are the songs he had played but he might want to play again, and which are the songs he has done playing, he won't play them again. So you can think as each of these songs in a different state, right? So it's all like the DJ is keeping track of them mentally, right? He's aware of the different states that these songs are in, and this piece of information is very crucial, because this will help the DJ to decide which song he can play next for his mashup. So this was how you can think about the process state diagram, or the life cycle of a process, how it is useful from the perspective of the operating system. The operating system, when it has these pieces of information, then it can properly do the time sharing. You can see how these pieces of information are very crucial for the DJ to make a decision as to which song it has to play next, right? So this was about the process state diagram and how it correlates with the DJ example. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in this slide, I have summarized all that we discussed in this video. So here in Basically, these are the concepts that we studied in the context of time sharing and how we can think about them using the music DJ analogy. Let me just summarize all of this once again. So we started with this idea that the program is very much like the music CD, and the process is very much like the music CD being played, right? And then we extended this idea further to cover more concepts from time sharing. So in time sharing, what is there? There are limited number of CPUs and many programs that want to execute on the CPU. And in order to tackle this problem, the operating system time shares the CPU among the different programs. So we created an example, a DJ example, where very similar to this time sharing, what we had was a music player, and the constraint was that this music player can play a single song at any given point in time. And then there was a DJ who wanted to create a music mashup by playing different songs in some order, right? So basically, there were many songs that he wanted to play, and there was only one music player. So he will have to play all of these songs by one at a time, switching between them, right? He will play one song, then switch to some other song, and in this way, by switching the songs, he can create a mashup using the music player. So you see how we can draw parallels between the two situations. The CPU was our resource in the first case. In the second case, our resource is the music player. On the CPU, we wanted to run programs. Here, we wanted to play the music CDs. And how did we play many how did we execute many programs on limited number of CPUs? By time sharing, right? So in the same way here, in the case of the DJ example, here he will be switching the songs frequently on the music player so that he can play many songs, right, and create a mashup. And finally, who is responsible for doing all of this? In the first case, it was the operating system. In the second case, it was the DJ. Finally, we discussed some other points also, like in how a program becomes a process, right? That journey of loading a program into the memory and creating a process. So basically, the activities that the operating system does in order to create a process out of a program is very similar to what the DJ does. Whenever he has a song to play, he will take that music CD, figure out, like, first of all, search the music CD from the collection, then load the music CD into the player, and then do some settings, and then he can play. So this process, like, that is loading the CD into the music player, is somewhat similar to how the operating system loads the program on the CPU and creates a process. Then we talked about how we can correlate the part where we had the challenge of representing a process, and we use the process control block. So we can correlate this with the example, like in the case of the DJ, he has to keep track of all the songs that he's playing, so that if he pauses one song, then he might he should be able to resume it from the point he had left. So how can he represent a song? Just like in the case of the computer, the operating system, in order to represent a process, it collected all of the relevant pieces of information, right? In the similar way, the DJ, he will be remembering all the relevant pieces of information that is relevant to a song. He can remember at which point the song is playing, or at which point he has left the song the last time, at what volume is the song playing, right? What are the settings using which he's playing the song. So whenever he pauses a particular song, if he remembers all of this, he can resume the song exactly from where it had left. The final idea was that of the process state diagram, right? The operating system has to keep track of all of the different states that a process can be in, and it is very crucial for performing the time sharing. So in the similar way, we can think in the case of the DJ has to have an idea of how the different songs are in different states. Like, there are some songs which he has played, some there might be one song that is currently playing, then there might be some songs which he has played previously and has put on hold, and finally there are certain songs that he has played and won't be playing again. So remembering which song is in which state helps the DJ to make a decision as to which song should he play next. So this is how we can correlate the process state information with the this DJ example. So guys, this was it for this video. In this video, I tried to create an analogy, right? This is obviously a made up analogy, so that the goal of this video was to help you think about the time sharing concepts in a more like practical and real life example. So I hope this analogy was interesting and helpful for you in understanding the different concepts that are there in the time sharing. So whenever there is any concept that is related to time sharing, if if you are able to correlate with this DJ example, then I feel you have understood time sharing in a proper way. So guys, this was it for this video. Thank you very much for watching, and I'll see you in the next video. Thank you.